It's now time for us to be able to turn the page and take a little bit of a talk with Microsoft Azure. And honestly, I'm just pleased to be able to go ahead and talk to a gentleman that I've known for a while and has been working at Microsoft for quite some time. He's got his head in the clouds. We have Mark Russinovich, CTO of Microsoft Azure, joining us remotely today. G'day, Mark. How you doing?
Rick, doing good. Good to see you again.
Oh, it's good to talk to you about some Azure stuff and some stuff that's coming up and some upcoming sessions that are there. But, you know, for the man that probably had one of the first Azure regions built out in his garage, I figured it'd be fitting to have you as the first guest to talk about some Microsoft Azure stuff. But before we start, like I knew you as a technical fellow, and then you became the CTO of Azure. And then as we were chatting, talking about this interview, you mentioned now that with the CTO, you actually have an office and a whole bunch of different facets within inside of that office. And so can you actually explain to me a little bit about what is the office of the CTO and how that works for you and for Azure?
Yeah, well, this is a little bit of my own transformation journey that started back when I entered software, which was basically as an individual contributor my entire career. Even when I started Winternals, the software company that I eventually sold to Microsoft, I didn't have anybody reporting to me. I called myself Chief Software Architect after Bill Gates's title. And when I joined Microsoft, I became a technical fellow and worked in Windows initially, again as an IC. Then I moved to Azure in 2010, shortly after the launch of Azure. And again, it operated as an IC. But over the years, as I was doing more and more presentations, I thought it'd be helpful to have a technical assistant that could help me research things as well as help me prepare for presentations and set up demos. So I hired a TA, and then that TA, Hashi Bai, actually ended up being extremely creative and came up with some cool ideas for incubations. We hired some more people, including Yaron Schneider, another TA. And he was also incredibly creative and came up with some more ideas that we kind of started to incubate. And I realized, looks like I've got what's forming here as an incubations team. Also, we have an open source effort, obviously, that many people are aware of, working inside of Microsoft also with the partner community and the open source ecosystem, including relationships with companies like Red Hat and HashiCorp and Canonical. And that made sense to have centrally located in a team that could be in office of the CTO. And so I started to build these sub-teams under me, including an incubations team, the open source ecosystem team. Then last year I formed a quality engineering team, which is focused on to what we could do at the core platform to raise the quality and make it easy to develop high quality services across the Azure platform. That now has morphed into an architecture team. The quality engineering team has moved to a different office under Henry Sanders, who's now the CTO for platform and edge. And then I also have another team that's started up, which is also essentially an incubations team, but one that's focused on large scale machine learning, model training, inference as a service. So being able to deploy jobs in a serverless way and take advantage of CPUs, GPUs, FPGAs, and custom accelerators for ML. And that is kind of, let's figure out what this looks like, what it needs to do, come up with some cool innovations in this space, and then eventually transition it to an engineering team. So now I have 4 teams under me, more than 50 people. So I never thought I'd be a manager, but here I am as a manager.
Well, now I'm going to have to absolutely double check all my job searches internally to find out if there's any openings under Mark Russinovich's CTO organization for sure. But can you kind of highlight one of those particular things that, because you mentioned it's incubation. Now, incubation, you're supposed to come to fruition with an actual product and have it spin off into the Azure world. Do you have any examples of anything that's actually done that kind of spin off and turned into something that's now a product that Azure people and Azure customers can go off and use?
Yeah, well, the team has had a number, like I mentioned, of ideas, some of which we haven't taken much further beyond an ideation phase. Some of it ended up in prototypes, but we've put it on the shelf, maybe come back to revisit. But there have been some cool innovations that have come out that have made it out into the public. One of them is Kada, the Kubernetes event-driven autoscaler, which is an open source project now as a CNCF sandbox project. That came out of the incubations team when it was just a handful of people. Mm-hmm. And then we transitioned that to an engineering org, the app service team that then took it and got it ready for contribution to CNCF and got it up to that standard. But the other two that we've got still under active development that are public, and we announced this almost exactly a year ago at Ignite, right before Ignite rather, is Open Application Model, or OAM, with implementation for Kubernetes called Rudder, and Dapper, the Distributed Application Programming Runtime. And I've got the Dapper swag on right here, the hoodie and the
Yeah. Now, you cover CADA, and you also cover Dapper and other stuff like that inside of your session. Now, I did do a check, and the session is available inside the session scheduler. Just if you look for a Mark Russinovich with air quotes around them, you'll be able to find that particular session. That's like an hour and a half long session. That's compiled together. It's I listened to you at 1.5 speed just to be able to finish off just before we started talking now. But you broke the session down into 6 different segments, and I'm just curious if you could kind of highlight maybe one thing that kind of stuck out for you while you were recording that particular session that was of interest to you from those 6 different segments. It was inside Azure data center architectures.
Yeah, actually, so that's a tough one, picking out one thing to highlight, and I don't know if I'm going to.
It's like trying to choose your favorite child if you're a father or something like that. So
exactly, there's so many cool new things that I show off there. Work from, I guess if I had to pick one, I think just because it's I don't know, there's something that tickles me about this, and that is the holographic storage project that we've got going with Microsoft Research Cambridge, where I show a demo of storing a page from my book 0 Day in a piece of holographic crystal and then reading it back out. That promises to be a disruptive technology in the area of warm storage, or kind of replacement for hard disks.
Right.
People probably have heard of Silica, which is our quartz glass storage solution that is aimed at archival media. But what's been missing is something that is low cost and high scale and delivers a consistent IOPS with respect to capacity growth that hard disks are simply not, and that is holographic storage. So it's like really cool, the idea of storing data inside of holographic crystals, and then being able to read it out.
Yeah. Now, just for people to know, when you go take a look at that particular session, in each one of these 6 sections that he breaks it down to, he's got demos for all this different sort of stuff, and so you do see that one there. I was impressed with seeing kind of the workbench for what it looked like for the DNA storage, which you also talk about as well, which is very much in the early stages of stuff. But you know, I'm a rack and stack server geek at heart and that sort of stuff, and so when I did work inside the Azure Compute team, working for Corey Sanders, at the time we were all excited about what was known as the Godzilla machines because they were so large at the time. And you do a phenomenal graphic explanation of all the different iterations that happened to go there. Now, I'm not going to ask you to quote the sizes of the different machines because that would be unfair. But do you have anything into the insight for how you go off and try to manage and choose to name some of these sizes? And if you could talk a little bit about the size if you want to, but I could help you cheat with some of the stats if you want.
Yeah, well, the Godzilla machine, I've talked about these publicly at various Inside Azure talks over the years at Ignite. 4 or 5 years ago, I introduced the Godzilla server, and we just called it Godzilla internally. And then when it came time to name that series of virtual machine types, we just called it the G series, which the internal joke was, that's Godzilla. Then we came out with a larger machine that was 512 gigabytes of RAM. Then we came out with a 4 terabyte RAM machine, and we said, what can we call this? Well, this is kind of a beast of a machine, so we called it internally Beast. That became the M series. And then we launched the Mv2, which is 12 terabyte virtual machines. And then I give a preview of a machine that's coming, a virtual machine type that's coming, which is going to be the Mv3 series, and that is, we're like, what do we call this? Well, I don't know if the team's calling it something else, but I decided to call it Super Mega Beast. Because the 12 terabytes one, by the way, I internally called Son of a Beast.
Yeah, the Mega Godzilla Beast or the Super Godzilla Beast was, I think, 24 terabytes of RAM, 488 CPU cores that you can go off and use. And then this obviously is going to be able to run some of the largest SAP workloads that are out there and be able to be provisioned for different resources, different systems that are out there. You also talked about a really neat technology, and again, you showed a really good demo for it, for what it was, and that was the concept of disaggregated architecture. Could you talk a little bit about that to the folks that are here? Just the background about it, and you know, when do you can't say when it's going to be available, but you did some great examples of it.
Well, the challenge with the server architecture is that you take a box, you put a bunch of things in it, you put GPUs, you put disks, you put CPUs, you put RAM, and then you deploy workloads onto that box. And the challenge that we run into is if the workload doesn't need all the resources, like if you're deploying a virtual machine that isn't the full server in size, then you've got some leftover resources. So you put in another VM that fits in that remaining space and consumes some resources. But almost inevitably, you end up with servers that you just can't fit virtual machines onto. And just as the life cycle of virtual machines come and go, they create holes in the capacity effectively that are stranded. And so this is what contributes to cost of the base cost of cloud is just these unused resources. And so the vision has been from the start of Azure, if we could get to a world where we just had giant pools of resources. In fact, you can take a look at the cloud from an outside perspective, just looks like a giant pool of resources. Inside, we've got these boxes of resources. If we could make pools even at that level of the infrastructure, then we could get rid of this fragmentation, this internal waste problem. And so the key to that is disaggregating the server. If you could blow it up and say, here's a giant pool of RAM, here's a giant pool of GPU, here's a giant pool of CPU, and then you could combine them on demand and say, I want 8 cores and I want X hundred gigabytes of RAM and I want 5 GPUs or 6 GPUs. You get these custom sizes, you get the ability to not end up with these local islands of wasted resource. And so one of the demos that I show in the talk, which is I think a really cool one, is we're exploring this, disaggregating all the resources. But one of the prototypes we got is taking the GPUs out of the server, connecting them with optical cable, with FPGAs on each side as part of this prototype that eventually be hardened into ASICs that present them as PCIe devices to the local servers. So the server thinks, oh, I've got a graphics GPU sitting here on the PCIe bus. It's actually sitting over in another server with an FPGA over there, making it also local over there. And then I'm talking to the GPU and with an optical cable in between. Yep. And so that is kind of our steps towards this vision of full disaggregation, which really ends up creating a lot more flexibility and lowering costs.
Yeah, so I was half expecting to see one of these types of setups in the shelving behind you at your house to be able to kind of demonstrate it. But again, if you get a chance, you definitely want to go to your backpack inside of myignite.microsoft.com and put a copy of this particular session into your backpack. I don't recommend watching it at fast speed. You want to potentially slow it down so you can catch all the goodness that Mark is talking about inside the session. But if you're anything about learning about data centers and hyperscale cloud and all the innovations that we're packing into that, the session basically covers it from front to back for a good, as I mentioned, a good hour and a half or so. It was really, really interesting for there. Now, there was some news recently about us going ahead and actually removing one of the subsea data center regions. I think it's Natick, if I'm pronouncing that correctly. Yeah.
Natick, yeah.
Yeah, so can you share any learnings that we had from that? That was kind of interesting that, it's been running now for 18 months or so, as you said. Anything you want to share about that kind of innovation architecture and how we can possibly apply it to our current architecture?
Yep, so just on the background of that, and I'd cover this in the server part of the talk, I talk about our server generations going back to before even cloud got started and how we architected our data centers and then move forward. And kind of this Natick is a step looking towards the future, kind of like disaggregation is. Mm-hmm. The idea here was that if we drop cylinders full of servers racks to the bottom of the ocean floor, we get a ton of benefits, including the ability to rapidly deploy data center capacity because it's just package up cert racks in a cylinder, drop it to the ocean floor. You get a cool environment on the ocean floor. You get to take advantage of power from currents, for example, from the ocean floor. Mm-hmm. And so power costs go way down. In fact, we could get data center efficiencies that are far better than what we've got today. But then one of the key requirements of this is that you can't be sending scuba divers down to take out servers and replace the disks. And, so we got to have these servers last for a few years with minimal failures. And one of the theories was if we have them at these constant temperatures on the ocean floor, if we take all of the water vapor out, all the oxygen and hydrogen gas, the molecules that are in a typical land-based data center, if we just evacuate that and replace it with inert nitrogen, then maybe that also can contribute to the longevity of those parts and get us to the point where this is a realistic scenario. And maybe we could even apply that in land-based data centers as well, this kind of lights out, degrade in place behavior or approach to data centers and servers. Mm-hmm. And so the experiment was we took 1,000 Azure servers, we divided them into multiple control groups, some at constant temperature, some at fluctuating temperature, 3 of those control groups with nitrogen gas, 1 of them standard air, and then compared the failure rates of all the 4 control groups. And what we found is that the biggest influence on failure rates by far was nitrogen gas versus air, just inert versus potentially corrosive oxygen with water vapor in the atmosphere, and the failure rate's 1/8 with that environment versus a typical kind of land air based environment. So a really cool learning came out of that, and we're working on an Edict V3. I've talked about a little bit before about this, of putting multiple of these cylinders together on gantries that connect them together, and we can get up to sizes that are Azure region and Azure availability zone and region sizes in terms of megawatts.
Now, just to be confirming this, that we don't actually have any of these regions we can deploy to, so I can't have it from a drop-down list, or is a selection inside of my ARM template or anything else like that? So you still have to wait for that.
Yeah, not yet, but although for these servers that we did have in the Natick underwater region, we donated that CPU capacity for COVID-19 simulation, molecule simulation, molecular dynamic simulations for partners that we had investigating the behavior of the COVID-19 molecule. So the servers, while they were part of this experiment, did go to good use.
Oh, that's good. That's good. Now, we're getting close to the end here, but I do know there's again, a whole bunch of other different topics inside of that talk that we could talk endlessly about. I do want to bring in some discussion around the networking side, because there's a really good practical example of what we called centralized network management being available now, or in the very near future that's coming out. I'm just curious if you have any stories where you've heard this possibly impacting a customer. That was the business case to go off and justify creating something like this, and maybe talk a little bit about the concept of centralized network management.
Yeah, so Central Network Manager, that's the current working name for it, and it's something that we're going to be launching. It's in private preview. We're going to be having a public preview at some time in the near future, and I show a demo of it and talk a little bit about it. But it came from us working with customers, and as these large customers come onto the platform and they've got thousands of resource groups, they've got virtual networks defined for groups of resource groups as well as individual resource groups, and networking has become incredibly complicated, especially when you want these different applications to communicate with one another. So what they've had to do up to this point is create peering relationships. So you can say this VNet A, peer it with VNet B, peer that with VNet C, but this creates this cross-dynamic mesh of peering relationships that's really hard to manage, really hard to understand what's going on. Mm-hmm. And so working with these customers, really what they want is a couple of topologies. They want to take a bunch of virtual networks and say, put these all together, peer them all together. Or they want kind of, hey, let me create a hub virtual network and let me peer spokes to that, so that the spokes can talk to the hub, but not necessarily to each other. Those are the kind of 2 topologies that came out of us working with them. And so that's exactly what Centralized Network Manager does, is let you create these kind of groups of virtual networks. Just drop the groups in, or even have them dynamically participate in it through tags, and then define these relationships, full mesh or hub and spoke.
Yeah, so again, you did a great demo being able to explain that, and that's definitely one of the big takeaways that I got from that particular session, was that this is very close now. I'm glad to hear that's going to be in a private preview now, and it's going to be in a public preview in the not too distant future for people to go off and to be able to sign up for that one there. Now, we've got just about a minute left, and I do want to call out that on one of the tweets that you had just recently, that you were taking some time to kind of go off and explore some other non-technical stuff. And I gotta give you props, man. You did a really good drawing of an X-Wing fighter, I gotta say. Is that something you've been doing for a while now, or is that just the last 6 months that you developed those skills?
Well, I've always had kind of a natural talent for drawing, and so I drew a lot growing up in my spare time. And then I kind of, as I went to college and grad school, I stopped drawing, basically. And then I revisited it at one point during grad school, spent about a month drawing again, and then let it lapse. So really haven't drawn since early 1990s. And then a few weeks ago, I'm like, you know what, I should pick that up again and just start playing with it. So I ordered a bunch of art supplies that I didn't have anymore. And then over the weekend, I'm like, oh, what's a fun project to do? Well, an X-Wing fighter. Let me start with that. And so really, that's the only drawing I've done in 20 years or so. It turned out much better than I hoped. Still, when I look at it, I see the mistakes in it. But for a first try back at drawing, I thought I was pretty pleased.
Yeah, definitely very good. I'm going to go ahead after this segment, and I'm going to tweet that one out again just so people can see it. Mark, thank you so much for joining us today. I really appreciate you taking the time out of your schedule to be able to help us here at Microsoft Tonight. Don't forget to go off and take a look at that schedule session of Inside Azure Data Centers and innovation going on. We've got a ton more in store for the Azure team today, and I'm so excited to be able to be here to help kick things off. But, well, what's next?